Hello guys, welcome to Networking for Ethical Hackers and Penetration Tester. My name is Akash Valaskar and I am your instructor for this course. I am a penetration tester trained to provide informative and accurate answers to your question. When I was learning networking, I often wondered which topics were necessary for a penetration tester to master. I knew that networking was an essential skill for ethical hacking and everyone recommended learning it. However, I was unsure about where to start and which topics were most important. I realized that I was not the only one with this question, and many others were likely wondering the same thing. That's why I am here to help you. Don't worry, I will guide you through the essential of a networking for penetration testing. So let's get started on this exciting journey of learning together. Okay, networking for ethical hacking and penetration tester is an introductory course designed to provide a comprehensive understanding of a computer networking relevant to ethical hacking and penetration testing. The course covers fundamental concepts such as IP, MAC, and port number, as well as how devices communicate and different types of networks. The course then progressed to cover the TCP/IP protocol suite and application layer protocols, with a focus on network security topics such as firewalls, VPNs, etc. Students will also learn about tools and techniques for detecting and preventing cyber attacks, including intrusion detection system IDS and intrusion prevention system IPS. The course also covered denial of a service, DOS, malware, and phishing attack and how to handle them. By the end of the course, students will have the skills and knowledge necessary to analyze and secure networks against cyber attacks. This course is ideal for anyone interested in pursuing a career in network security or ethical hacking, or for those who want to learn more about how networks work and how to secure them. No prior networking experience is required. Okay, so our first section is the importance of networking in ethical hacking. Why the networking is important for ethical hacking? Networking is a crucial in ethical hacking as it provides a foundation for understanding the way computer systems and their components interact with each other. By networking, we mean the process of connecting computer systems together to enable them to share data and resources. In ethical hacking, a strong understanding of networking is essential because it allows you to identify vulnerability in a network and exploit them to gain access to sensitivity information or control of the system. For instance, an ethical hacker must understand how data is transmitted across a network, how packets are handled, how different protocol works, and how to identify and exploit vulnerability in network devices such as router, switches, and firewalls. Furthermore, networking knowledge is important when it comes to conducting penetration testing, which is a critical component of ethical hacking. Penetration testing involves simulating an attack on a network to identify security weaknesses that could be exploited by real attackers. Without a thorough understanding of networking, it would be challenging to conduct such tests effectively. Let's say an ethical hacker is conducting a penetration testing on a company's network to identify vulnerability. The first step in the process would be to gather information about the network, including its architecture, the devices connected to it, and the protocols used for communication. With a good understanding of networking, the hacker would be able to identify potential entry point into the network, such as ports on routers or firewalls, unsecure wireless access points, or weak passwords on user account. Once these vulnerabilities are identified, the hacker can exploit them to gain unauthorized access to the network and the sensitive information it contains. Without a strong understanding of networking, the ethical hacker might miss critical vulnerabilities, which could leave the network and its data at risk of being compromised. Therefore, networking is a critical skill for an ethical hacker, and it is essential to ensure the security of our computer systems and networks. Okay, so what is computer network? A computer network is a group of interconnected devices that can communicate and exchange information with each other. The devices can be computers, printers, servers, routers, switches, and other network enabled devices. In a computer network, devices are connected together by a physical medium such as cable or wirelessly through Wi-Fi or Bluetooth. Networks can be small, such as those found in homes or offices, or large, such as those used by a multinational corporation or the internet. The purpose of a computer network to enable devices to share resources such as data, files, printers, and internet access. Networks allow individuals and organizations to communicate and collaborate, make it easier to work together and share information. Computer networks are designed using various topologies such as bus, star, ring, and mesh, each with its own advantages and disadvantages. Network protocols such as TCP/IP are used to ensure that the devices can communicate with each other efficiently and securely. How many types of computer network? First is local area network, LAN. A LAN is a network that covers a small geographic area such as an office, home, or school. An example of a LAN is the network of a computers and devices in a university computer lab, or the computers and devices in an office building. A LAN typically connects computer, printers, and other devices using Ethernet cable or Wi-Fi. LANs are designed to allow devices to communicate and share resources with each other. Second is wide area network, a WAN. WAN is a network that covers a large geographic area such as city, country, or even the world. An example of a WAN is in the internet, which is a global network that connects billions of devices around the world. WANs are typically used by businesses and organizations to connect their location together. WAN use various technologies such as leased lines, satellites, and the internet to connect devices together. Third is metropolitan area network, MAN. A MAN is a network that covers a city or metropolitan area. An example of a MAN is a cable TV network that provides internet access to homes and businesses with the specific city or a region. Fourth is personal area network, PAN. A PAN is a network that connects personal devices such as smartphones, tablets, and laptops. An example of a PAN is the Bluetooth network that connects a smartphone to a wireless headset or a laptop to a wireless mouse. Fifth is campus area network. A CAN is a network that connects multiple LANs within a university campus or a corporate campus. An example of a CAN is a university network that connects different departments or buildings with the campus. Sixth is storage area network, SAN. A SAN is a specialized network that provides block level access to a data storage. SANs are typically used in a data centers or a large enterprises to provide centralized and scalable storage for a mission critical application. An example of a SAN is a network that connects multiple servers to a storage device. Seventh is wireless local area network, WLAN. A WLAN is a LAN that use wireless communications technologies such as Wi-Fi to connect devices instead of Ethernet cables. WLANs are commonly used in homes, offices, and public places such as airports and coffee shops. An example of a WLAN is the Wi-Fi network in your home or office. The last one is virtual private network VPN. A VPN is a network that allows users to securely access a private network over the internet. VPNs are commonly used by businesses to provide remote access to their employee. An example of a VPN is a remote worker connecting to their company's network using a VPN client on their laptop or mobile devices. Next is Ethernet. Ethernet is a standard for a computer networking that allows devices to communicate with each other over a wired or a wireless network. An Ethernet cable, also known as a network cable or a LAN cable, is a type of a cable used to connect devices to an Ethernet network. Ethernet cables typically have a 4 pairs of twisted wires and comes in different categories such as Cat5, Cat6 and Cat7, which indicates the cable's performance and speed capabilities. Ethernet cables are also used to transmit data between devices such as computers, printers, routers and switches. The cable connected to a device's Ethernet port, which is a small rectangular port typically found on the back of a computer or a router. Ethernet cables are essential for creating a wired network, which is often faster and more reliable than a wireless network. Now, a hub. Hub is a networking device that connects multiple devices on a network and allow them to communicate with each other. A hub is essential a central point of a connectivity where device can connect and share data. When a device sends data to a hub, the hub broadcasts the data to all devices connected to it. This means that all devices receive the data even if it's not intended for them. As a result, hubs are considered to be less efficient and less secure networking solution than switches or routers. Here is an example of how a hub works. Let's say you have 4 computers in your home office that you want to connect to a network. You can connect all 4 computers to a hub using Ethernet cable. The hubs will then allow the computers to communicate with each other and any data sent by one computer will be broadcast to the other 3 computers. However, if 2 computers trying to send data at the same time, a collision may occur which can cause a data loss or corruption. This is because the hub cannot prioritize traffic and simply broadcast all data to all connected devices. Switches. A switch is a network device that connects devices together on a computer network. It works by receiving data packets and forwarding them to their intended destination. Switches operate at the data link layer, layer 2 of the OSI model, and are responsible for forwarding data between devices on a local area network. When a device sends data to switch, the switch examines the data destination addresses and send it only to the device that it intends to receive it. This eliminates the need for the data to be broadcast to all devices connected to the network, which reduces network congestion and increases security. Let's say you have a small office with 20 computers, all connected to the internet through a single router. You decide to upgrade your network by adding a switch. You connect all 20 computers to the switch using Ethernet cable. When a computer wants to send data to another computer on the same network, it sends the data to the switch. The switch then checks its routing table to determine which port the destination computer is connected to and send the data directly to that computer. This is different from using a hub, where data sent to one computer is broadcast to all the computers on the network, causing unnecessary network congestion. By using a switch, the network becomes more efficient and data is delivered more quickly to the intended destination. Switches are commonly used in both small and large networks, such as those found in home offices and data centers. They come in various sizes and speeds, with some switches supporting hundreds or thousands of devices at once. Next is a router. A router is a networking device that connects multiple networks together and forward data packets between them. It is used to connect a local network such as LAN or WLAN to the internet or another remote network. Router operates at the network layer 3 of the OSI model and uses IP addresses to route data between networks. It uses routing tables to determine the best path for a forwarding packet from one place to another. The routing table contains information about the network addresses and associate the routes for a forwarding data. Routers work by examining the destination of an address and forwarding it to the correct network. For example, if you want to connect a website, your computer sends a request to your router. The router then examines the destination IP addresses of the request and forward it to appropriate network to retrieve the website data. Routers can also perform other functions such as managing network traffic, filtering data, and providing security features like firewalls. Here is an example of how a router works. Let's say you have a home network with the multiple devices, including computers, smartphones, and tablets. You want to connect your network to the internet, so you connect your router to your modem. The router then connects your network to the internet, allowing devices on your network to access websites, send emails, and stream videos. Routers are commonly used in homes, businesses, and data centers. They come in a various size and speeds, with some routers supporting hundreds or even thousands of devices at once. Our last topic on introducing to networking, the topic name is network topology. A network topology refers to the physical layout of a network. It defines how devices are connected to each other and how data is transmitted between them. There are several types of networking topologies, each with its own advantage and disadvantages. Here are some common ones. First is bus topology. In a bus topology, all devices are connected to a single cable called a bus. Data is transmitted between devices by sending signals along the bus. This topology is simple and inexpensive, but it can be slow and difficult to troubleshoot. If there is a problem with the cable, an example of this topology is the local area network LAN in an office. Second is star topology. In a star topology, all devices are connected to a central device such as switch or hub. Data is transmitted between devices by sending signals to the central device, which then forwards the data to the recipient. This topology is easy to manage and troubleshoot, but it can be expensive because it requires a central device. As an example of the topology is a home network with the wireless router. Third is ring topology. In a ring topology, all devices are connected in a loop. Data is transmitted between devices by passing it around the loop in a one direction. This topology is fast and efficient, but it can be difficult to troubleshoot. If there is a break in a loop, an example of this topology is token ring network. Fourth is mesh topology. In a mesh topology, each device is connected to multiple other devices. Data is transmitted between devices by sending it through the shortest possible path. This topology is very reliable because it allows data to be routed if one path is blocked, but it can be expensive because it requires a lot of connections. An example of this topology is a wide area network WAN used by large corporations. The last one is hybrid topology. A hybrid topology is a combination of two or more topologies. For example, a network could have a star topology at the center with the bus or ring topologies connected to it. This allows for a flexibility and can be a good choice for large networks. As an example of this topology is a school network that combines a star topology for the main building with the bus topology for each classroom. Okay, so our next section is TCP/IP protocol suite and application layer protocol. The first is OSI model. The OSI, the Open System Interconnection model, starts from the bottom with the physical layer, which is the first layer in the model, and then moves up through the 7 layer, ending with the application layer, which is the seventh and the top most layer in the model. So the OSI models start from the physical layer and end with the application layer. The OSI model is a way of breaking down the communication process between two devices in a network. It has 7 layers each with its own specific function. First is physical layer. This layer is responsible for transmitting raw data over a physical link. It handles tasks like signal encoding and modulation. For example, when you use a wired Ethernet connection to access the internet, the physical layer of the OSI model is responsible for transmitting data over the Ethernet cable. Second is data link layer. This layer is responsible for providing reliable data transfer across a physical link. It handles tasks like error detection and correction. For example, when you connect to the internet using Wi-Fi, the data link layer of the OSI model is responsible for ensuring that the data is transmitted correctly over the wireless network. The third is network layer. This layer is responsible for addressing and routing data between different networks. It handles tasks like logical addressing and packet routing. Example, when you send an email to someone in a different country, the network layer of the OSI model is responsible for routing the email from your local network to the recipient's network. Fourth is transport layer. This layer is responsible for end-to-end delivery of a data. It handles tasks like flow control and error recovery and segmentation. For example, when you download a file, the transport layer of the OSI model is responsible for ensuring that the data is delivered to a device correctly and the correct order. And in the correct order, the fifth is session layer. This layer is responsible for managing the communication sessions between applications. It handles tasks like session start, set, maintenance, and termination. For example, when you log into a website, the session layer of the OSI model is responsible for setting up the connection between your device and the website's server. Second last is presentation layer. This layer is responsible for formatting and presenting data to the application layer. It handles tasks like data compression and encryption. For example, when you send an encrypted email, the presentation layer of the OSI model is responsible for handling the encryption process. The last one is Application layer. This layer is responsible for providing service to the end user. It includes applications like web browsers, email clients, and instant message programs. Okay, so if you don't understand the OSI model, I explain you in a more easy way. See the table, example of a common protocols and technologies associated with each layer. First is common physical layer technologies include Ethernet, cables and hubs. Second one is common data link layer technologies includes MAC, media access control, addresses and switches. Third is common network layer protocol include IP, Internet Protocol and ERP, Address Resolution Protocol. Fourth is common transport layer protocol include TCP, Transmission Control Protocol and UDP, User Datagram Protocol. Fifth is common session layer protocol includes NetBIOS, Network Basic Input Output System and PPTP, Point to Point Tunneling Protocol. Sixth is common presentation layer protocol include SSL, Secure Socket Layer and TLS, Transport Layer Security. Seventh is common application layer protocol include FTP, File Transfer Protocol, HTTP, Hypertext Transfer Protocol, and DNS, Domain Name System. Overall, OSI model provides a framework by understanding how device communication occurs between devices in a network. By breaking down the process into a specific layer, it makes it easy to troubleshoot network issue and develop a new technologies. Next is TCP/IP model. The TCP/IP model is a four-layer protocol stack that is used for communication over the internet and other networks. It consists of the application layer, transport layer, internet layer, and network access layer. First is network access layer. This layer is responsible for transmitting data between devices on the same network. It includes protocols like Ethernet, Wi-Fi, and Bluetooth. For example, when you connect to a Wi-Fi network, your device uses the Wi-Fi protocol to send and receive data from other devices on the same network. Second is internet layer. This layer is responsible for routing data packets between different networks. It uses the IP Internet Protocol to identify the source and the destination of a data packets. For example, when you send an email to someone in different country, the email data is broken down into smaller data packets that are routed across multiple networks using the IP protocol. Third is transport layer. This layer is responsible for providing reliable data transfer between two devices. It includes two main protocols, TCP, Transmission Control Protocol, and the UDP, User Datagram Protocol. For example, when you download a file from the internet. For this application layer, this layer is responsible for handling users, applications, and protocols. This layer is include protocols like HTTP, FTP, SMTP, and DNS. In ethical hacking, understanding the TCP/IP model is important for analyzing network traffic and identify potential vulnerability in a network. TCP/IP model is a similar like a OSI model. So let's find out what's difference in OSI model and a TCP/IP model. So what is difference between OSI model and a TCP/IP model? TCP/IP and OSI are both networking models, but there are some difference between them. Here are some key differences. Network of a layer. TCP/IP has a 4 layer while OSI has a 7 layer. Protocols. TCP/IP models has a smaller set of protocols while OSI model has a large set of protocol. Functionality. TCP/IP is a more practical and a less formal model, while OSI is a more theoretical and formal model. Implementation. TCP/IP model is a more widely used and implemented in a practice, while OSM model is a mostly used for teaching and conceptual understanding. Okay, so see the table now. In TCP/IP model, the application layer, presentation layer, and session layer from the OSM model are combined into the fourth layer called the application layer. The transport layer and the network layer in the TCP/IP model are equivalent to the transport layer and internet layer, formerly known as the network layer in the OSM model. In the TCP/IP model, the data link layer and the physical layer are combined into a single layer called the link layer. Our next topic is IP. What is IP? IP, Internet Protocol, is a fundamental protocol that is used for communication over the internet and other computer networks. Primary role is to enable devices to send and receive data packets across a network. An IP address is a unique numerical identifier assigned to every device on a network. This address allows the device to be located and communicate with the other devices on the same network or across different networks. There are two versions of IP in use today, IPv4 and IPv6. We will cover this later on this course. IP operates at the network layer, layer 3 of the OSM model, and is responsible for addressing routing and fragmentation of data packets. It works together with the other protocols such as TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, to prove reliable data transmission across networks. MAC, Media Access Control, refers to the unique identifier assigned to the Network Interface Control (NIC) of a device. The MAC address is the hardware address that is permanently assigned to the NIC by the manufacturer and is used to identify the device on a network. The MAC address is a 48-bit address, 6 bytes, that is represented in a hexadecimal format, usually written as a 12-character. Example like this. The first 3 bytes of the MAC address represent the manufacturer of the NIC, while the remaining 3 bytes represent a unique identifier assigned to the NIC by the manufacturer. MAC addresses are used in local networks such as Ethernet network to identify devices and allow them to communicate with each other, unlike IP address. MAC addresses are assigned to the hardware of a device and do not change unless the NIC is replaced. MAC address operates at the data link layer 2 of the OSM model and are used by protocols such as Ethernet to control access to the network and transmit data packets between devices. Next is port. In computer networking, a port is a logical endpoint for communication in a network. Ports are identified by a number known as the port number, which allow data to be transmitted and received between network devices. The most commonly used ports numbers are standardized by the Internet Assigned Number Authority (IANA). For example, port number 80 is used for HTTP web traffic, while port number 25 is used for SMTP email traffic. Ports can be classified in two categories: well-known ports and dynamic ports. Well-known ports are a number from 0 to 1023, means 1023, while dynamic ports are number from 10242 to 65535. Well-known ports are assigned to specific service application, while dynamic ports are used for temporary communication between devices. In practice, ports are used to allow multiple network application or services to run on a single device. For example, a web server might use port 80 for HTTP traffic and port 443 for HTTPS traffic. Understanding ports is important in networking because it allows network administrators to control access to a specific service or application. Firewalls, for example, can be configured to block or allow traffic to specific ports based on a security policy. IPv4 addresses. An IPv4 address is a unique number that identifies every device connected to a computer network using the Internet Protocol version 4, IPv4. Communication protocol is like a phone number that helps computers to talk to each other on the internet. IPv4 addresses are made up of 32 bits, which are string of ones and zeros. To make it easier for humans to read and remember, these bits are usually represented as a 4 decimal numbers separated by periods. For example, the IPv4 address is 192.168.0.1 could represent a device such as a computer or a printer that is connected to a network. Although IPv4 addresses are still widely used today, there are a limited numbers of them available, which means that as more and more devices connected to the internet, the number of available addresses will eventually run out. This is why a newer addressing system called IPv6 has been developed, which uses longer addresses allows for a much large number of a unique address. IPv6 is gradually being adopted, but it will take some time for it to become the standard for internet communication. Second is IPv6 addresses. IPv6 is the latest version of the Internet Protocol IP, which is designed to replace the previous version IPv4. One of the main differences between IPv6 and IPv4 is the size of their address formats. IPv6 addresses are made up of 128 bits, which allow for a much larger number of unique addresses than IPv4. This is important because as the number of devices connected to the internet continues to grow, we will eventually run out of unique IPv4 addresses. IPv6 addresses are represented as 8 group of 4 hexadecimal digits separated by colons. This makes the addresses longer and more complex than IPv4 addresses, but also allows for a more unique addresses to be created. For example, an IPv6 address might look like this. Another advantage of a IPv6 is that includes built-in security features such as IPsec, which provides encryption and authentication for a network traffic. This makes it easier to ensure the security of a network communication, which is increasingly important as more sensitive data is transmitted online. Overall, transition to IPv6 is important for ensuring the continued growth and the stability of the internet, as well as providing improved security and simplifying network administration. It will help to ensure that there are enough unique addresses to support the growing number of devices continue to the internet and the connection between them remains secure. What is public IP address and private IP address? When a device is connected to a local network, it is given a private IP address by the router. The private IP address is used to communicate with the other devices on the same network. However, when the device needs to communicate with the device on the internet, the router translates the private IP address to a public IP address that can be used on the internet. The public IP address assigned by the Internet Service Provider ISCP and is visible to the internet. Think of the private IP address as your home address, which is used to communicate with your family members who lives in the same house. The public IP address is like your post office box address, which is used to communicate with the people outside of your house, such as your friends and relatives who lives in other place. The router uses a process called network address translation (NAT) to translate the private IP address to the public IP addresses. NAT allows multiple devices with the private IP addresses to share a single public IP address, which is important because there are several limited numbers of public IP addresses available. Next is ERP, Address Resolution Protocol. ERP is an important protocol used in the local area networks (LANs) to help devices communicate with each other. It works by mapping network addresses to physical addresses, which are unique identifiers assigned to each device's network interface card (NIC). When a device needs to communicate with the another device on the same network, it sends out an ERP request message to ask for the physical address associated with the IP addresses of the destination device. The request is broadcasted to all devices on the network, and the device with the matching IP addresses respond with its physical address. Once the requesting device receives the physical address, it can then send data packets to destination device using that address. ERP is a key part of the data link layer of the OSI model and is essential for the proper functioning of a local area networks. Let's say you want to visit a friend's house but you don't know the address. You can look up their name in a phone book to find their address. In this analogy, the phone book acts like the ERP protocol and your friend's name and the address are like the IP address and MAC addresses of a device on a network. When you arrive at your friend's house, you write down their address in a notebook so you can find it again easily in the future. This is similar to how devices store the ERP mapping in their ERP table for further use. However, ERP can also exploited by attacker for a malicious purpose, such as ERP spoofing or ERP poisoning. In ERP, spoofing an attack sends a false ERP message to a redirect traffic to a malicious device. In ERP poisoning, an attacker sends a fake ERP message to associate their own MAC addresses with the IP addresses of another device, allowing them to intercept and manipulate network traffic. It is important to aware of these attacks and take steps to prevent them, such as using network security tools and monitoring network traffic for suspicious activity. Subnet. A subnet or subnetwork is a logical subdivision of an IP network. It is created by dividing a large network into smaller network segments to improve performance and manageability. Subnets are defined by a subnet mask, which determines the network addresses and host addresses. The subnet mask is a 32-bit value that is used to divide an IP addresses into a network and host portions. For example, if an organization has a Class C IP addresses range 192.168.0.0/24, it can be divided into smaller subnets by changing the subnet mask. A subnet mask of a 255.255.255.0 for slash 24 in CIDR notation would allow for up to 254 hosts in each subnet. To further explain, let's say that the organization wants to create two subnets, one for the sales department and one for the marketing department. They could divide the Class C IP addresses range of 192.168.0.0/24 into two subnets by changing the subnet mask to 255.255.255.128/25 in CIDR notation. This new subnet mask could allow for 128 host addresses in each subnet. The first subnet would have the network address of a 192.168.0.0 and the broadcast addresses of a 192.168.0.127. The second subnet would have the network address of a 192.168.0.128 and the broadcast addresses of a 192.168.0.255. By creating these two subnets, the organization can improve performance and manageability by isolating network traffic between the sales and marketing departments. This allow this also allow for a better network security by controlling access between departments. Overall, subnets are an important concept in a networking that allows for a better organization and management of a network resources. The last one is a routing table. A routing table is a table that contains information about the routes that a network device such as a router can use to forward data packets to their destination. It typically includes information about the destination network, the next hop router and the interface to use to reach that next hop router. Let's use an example of a person planning a road trip to across the country. The person is like a network device and the road are like the path that the data packets can take to their destination. Before starting the road trip, the person would need to plan their route by looking at a map and deciding which roads to take to reach their destination. In the same way, a router uses a routing table to decide which path to take to forward data packets to their destination. For example, let's say that a router has a two connected networks, network A and network B. The router's routing table would contain information about how to reach both of these networks, including the destination network address, the next hop router, and the interface to use to reach that next hop router. If a data packet comes into the router and is destined for a network A, the router would look at its routing table and see that the packet should be forwarded directly to network A. Using the appropriate interface, if the packet is destined for a network B, the router would look at this routing table and see that it needs to be forwarded to another router, the next hop router, before it can reach its final destination. Overall, a routing table is an important tool for a network devices to determine how to route data packets to their destination, and it allows for efficient and effective communication across networks. Okay, so our next section is network services. The first topic is TCP. What is TCP? TCP stands for Transmission Control Protocol, which is communication protocol that allow for the reliable transmission of a data between devices on a network. It is the one of the core protocol of the Internet Protocol suite along with the IP Internet Protocol. TCP uses a three-way handshake to establish a connection between devices. The sender sends a synchronized packet to the receiver. The receiver responds with the synchronized acknowledge packet, and then the sender sends an acknowledge packet to confirm the connection. TCP is a protocol that provides a reliable order and error check delivery of a data between applications running on different devices over a network. When two devices want to communicate with each other using TCP, they establish a connection first by using a process called three-way handshake. Once the connection is established, the devices can then send data to each other in a small chunks called segments. Example of a TCP three-way handshake. Imagine you want to have a conversation with your friend, but you want to make sure they are listening before you start talking. Here's how the three-way handshake works. First, you say, "Hey, are you there?" This is called sync packet. Your friend responds, "Yes, I'm here. What do you want to talk about?" This is called a sync ACK packet. You say, let's talk about these things. This is called the ACK packet. Now you both know that you are both ready to have a conversation. This is a similar to how a TCP connection is established between two devices. The three-way handshake is a way for the devices to ensure that they are both ready to exchange data before they start doing so. Next is UDP. UDP stands for User Datagram Protocol, which is a connectionless protocol that operates at the transport layer of the TCP IP model. Unlike TCP, UDP does not establish a connection before transmitting data and does not guarantee delivery in order of the data packets. UDP is often used for applications that require fast transmission of a data such as video, streaming and online gaming. Since UDP does not have the overhead of establishing a connection and ensure reliability, it can transmit data more quickly than TCP. Okay, so now UDP. However, this lack of a connection setup overhead make UDP faster and more lightweight than TCP. However, because UDP does not guarantee delivery or order of the data packet, some packet may be lost or received out of order. This makes UDP less reliable, which guarantee the delivery of all packets and ensure that they are received in the correct order. UDP is often used for applications that require speed over reliability such as real-time video and audio streaming, online gaming, etc. The next is DNS. The domain name system. DNS is a protocol used in a computer networks to translate domain names such as www.example.com into IP address that computers can understand. It acts as a phone book for the internet, translating human readable domain name into machine readable IP addresses. DNS work by using hierarchical systems of a domain names with the root domain at the top followed by a top level domains such as .com, .org and .net and then subdomains such as google.com or facebook.com. When you enter a domain name in your web browser, your computer sends a DNS request to a DNS server asking for the IP addresses associated with that domain name. The DNS server then searches its database for the IP address and return it to your computer, allowing your browsers to connect to the correct IP address and display the requested website. DNS also allows for a caching of a result, which can improve performance by reducing the need for repeated lookup frequently visited websites. For example, the IP addresses of a google.com is a 142.25.1.42.46. DNS can translate this IP address to a domain name that human can remember. Overall, DNS is a critical protocol for enabling users to access website other online services using human readable domain names. Without DNS, user would have to remember the IP address of every website they want to visit, which would be the both inconvenient and impractical. DNS simplifies the process by translating domain names into IP addresses, making it easier for users to access the online services they need. Our next topic is DHCP. DHCP is a protocol that allows devices to join a network and automatically receive the necessary network configuration information to communicate on that network. This includes assigning unique IP addresses to devices, which is important because IP addresses are what devices use to communicate with each other on a network. When a device joins a network, it sends a request for a network configuration information to a DHCP server. The DHCP server then responds with the necessary information which allows the device to communicate on that network. Let's use an example. A student entering a classroom Imagine you are a teacher and you want to assign a seat to a new student who has just entered the classroom. Here's how the DHCP can be compared to this process. First, the students enters the classroom. Just like a new device connect to the network, the students enter the classroom. Second, the teacher assigns a seat. Instead of manually assigning a seat, the teacher can use a DHCP server to automatically assign a seat to the student. Third, the student gets the seat and can start learning. Once the seat is assigned, the student can start learning without worrying about where to sit. In the same way, DHCP automatically assign IP addresses and other network configuration setting to the device as they connect to the network. This saves times and reduces the chance of errors when configuring IP addresses manually. DHCP can also assign other settings like subnet mask, default gateway, and DNS servers, making it easier for devices to communicate with each other on a network. Overall, DHCP is an essential protocol that simplifies network administration and reduces the chance of errors when configuring IP addresses on other network setting manually. It allows devices to connect to the network and start communicate with each other quickly and easily without the need for a manual configuration. Next is NAT. NAT stands for Network Address Translation. It is a technique used in a computer networking that allows multiple devices to share a single IP address to connect to the internet. NAT is commonly used in home and small office networks where there are more devices than available public IP addresses. NAT works by assigning a private IP addresses to each device on the local network, such as 192.168.1.2 or 10.0.0.3, which are not visible on the internet. When a device on the network wants to communicate with the server on the internet, NAT translates the private IP address to the public IP address of the router, allowing the communication to take place. This allows multiple devices to share a single public IP address, which conserves the limited supply of a public IP addresses and helps to secure the local network by hiding the private IP address from the public internet. Our last topic on this section is common network protocols. First is HTTP. Is a protocol used to transfer web pages and other web content from a web servers to clients. It operates on port 80 TCP and is commonly used for web browsing. Second is HTTPS. HTTPS is a secure version of a HTTP and operates on port 443 TCP. It is used for secure communication over the internet, such as for online banking, e-commerce, and other sensitivity information. Third is FTP. FTP is a protocol used for transferring files between clients and servers. It operates on port 20 TCP for data transfer and 21 TCP for control. It is typically used for website maintenance and uploading files to a web server. Fourth one is SSH. SSH is used for secure remote access to a computer or a server. It operates on a port 22 TCP and allows users to execute commands and transfer files securely over the internet. Fifth is SMTP. SMTP is used for retrieving email messages from a server to a mail client. It operates on port 110 TCP and is typically used by users who access their email using desktop email clients like Microsoft Outlook or Apple Mail. Seventh is IMAP. IMAP. IMAP is used for accessing email messages stored on a server. It operates on port 143 TCP and allows users to view and manage their email messages from multiple devices. Eighth one is DNS. DNS is used for translating domain names into IP addresses and vice versa. It operates on port 53 UDP and allows users to access websites and other resources on the internet using human readable domain names. Ninth one is DHCP. DHCP is used for assigning IP addresses and other network configuration settings automatically to devices on a network. It operates on a port 67 UDP for the server and a port 68 UDP for the client. 10th is SNMP. SNMP is used for managing and monitoring network devices. It operates on port 161 UDP and allows network administrator to monitor network performance, troubleshoot problems, and configure network devices. 11th is RDP. Remote Desktop Protocol is used for remote desktop connection and operates on port 3389 TCP. 12th is SMB. Server Message Block is used for file and printer sharing in Windows networks and operates on port 445 TCP. Last one is NTP, Network Time Protocol, is used for network time synchronization and you can use both UDP and TCP depending on the implementation. It operates on port 123. Our next session is on network security. First topic in network security is VPN and proxies. A virtual private network VPN and a proxy servers are two different technologies that are commonly used to help protect online privacy and anonymity. A VPN is a type of a network connection that creates a secure and encrypted tunnel between a user's device and a remote server. This tunnel protects the user's online activity from prying eyes such as hackers, government agency, and internet service provider ISP. A VPN also allows users to access geo-restricted content by masking the IP address and make it appear as though they are located in a different location. On the other hand, a proxy server acts as an intermediary between user's device and the internet. When a user makes a request for information, the request is sent to the proxy server, which then retrieves the requested information and send it back to the user. Proxy server can be used to hide a user's IP address and location and can also be used to bypass internet censorship and access block content. Imagine you want to send a secret message to a friend but you don't want anyone else to see it. One way to do this is to use a secret code that only you and your friend know. This is like a VPN. A VPN creates a secure and encrypted tunnel between your device and a remote server, which make it difficult for anyone to spy on your online activity. This can protect your online privacy and anonymity by hiding your IP address and make it seem like you are located in different location. For example, if you are in the UK and want to access a website that is only available in the USA, a VPN can make it seem like you are accessing the website from USA, allowing you to access geo-restricted content. Now imagine you want to send a message to your friend but you don't want anyone know that it's coming from you. One way to do this is to ask a trusted friend to act as a go-between and deliver the message for you. This is like a proxy server. A proxy server acts as an intermediary between your device and the internet and can be used to hide your IP address and location. Next is firewall. A firewall is a network security system that monitors and controls incoming and outgoing network traffic based on a predetermined security rules. It acts as a barrier between a private internal network and the public internet, allowing only authorized traffic to pass through while blocking an unauthorized traffic. Firewalls can be implemented in a hardware, software, or both, and can be configured to filter traffic by based on various factors such as IP address, port number, and protocol and application. They play a crucial role in protecting networks from cyber attacks and other security threats. For example, a firewall is like a guard that stands between a private internal network and the public internet. It keeps an eye on all incoming and outgoing traffic and only allow authorized to pass through while blocking any unauthorized traffic. It can be thought of as a filter that checks all the data that comes in and out of a network and only lets in the ones that meet the predetermined security rule. For instance, just like security guard at the entrance of a building checks the identity of a people coming in and only allow those with the proper authorization to enter. A firewall can be configured to filter traffic based on various factors such as IP addresses. This helps to prevent cyber attacks and security threats from infiltrating the network. Our last topic on network security is the IDS and IPS. Intrusion Detection System IDS and Intrusion Prevention System IPS are two network security technologies to use to monitor and protect computer networks against unauthorized access attacks and other security threats. IDS and IPS work by analyzing network traffic and looking for patterns that may indicate attempt security breach. Let's use an analogy of a security guard at a museum. The security guard is responsible for identifying potential security threats and taking action to prevent them. An intrusion detection system IDS, and IDS is like a security guard who is watching the museum for any suspicious activity. The IDS monitor network traffic and look for a pattern that may indicate a potential security breach, such as unauthorized access attempts or unusual network activity. Once the IDS detects a potential threat, it sends an alert to a network administrator or security personnel who can investigate and take appropriate action to prevent the threat. For example, IDS may detect an attempt to log into the network from an unauthorized device or unusual amount of a network traffic from a particular IP address. The IDS would send an alert to a network administrators or security personnel who could then investigate. The intrusion prevention system IPS. An IPS is like a security guard who not only detect potential security threat but also take an action to prevent them. The IPS monitor network traffic in a real time and use a predefined security policy to determine if a traffic is unauthorized or not. If the traffic is determined to be unauthorized, the IPS will take action to block or quarantine the traffic. For example, an IPS may detect an attempt to log into the network from unauthorized device and immediately block the traffic from that device. Or if the IPS detects unusual network activity from a particular IP address, it may quarantine that IP address and prevent it from accessing the network until the security threat is resolved. Overall, IDS and IPS are essential technologies for a network security that helps to detect and prevent security breaches by monitoring network traffic and looking for patterns that may indicate potential security threats. IDS and IPS can help to protect computer networks and their resources from unauthorized access, attacks, and other security threats. Our next section is the last of our course, detecting and preventing cyber attacks. The first is DOS attack. Denial of a service. DOS attack is a type of a cyber attack that aims to disrupt the normal functioning of a website server or network by overwhelming it with the traffic or a request. DOS attack can be launched by a single attacker or a group of attackers using multiple devices, and they can have a serious consequences including loss of revenue, reputation damage, and even complete network downtime. Imagine a restaurant with a limited number of tables and chairs. If a large group of people suddenly show up and demand to be seated, they can overwhelm the restaurant and prevent other customers from getting a table. Similar, a DOS attack sends an overwhelming amount of traffic or a request to a website server or a network, making it unavailable to legitimate users. Here are some common types of DOS attacks. Flood attack. First is flood attacks. This type of attack is involves sending an overwhelming amount of a traffic or a request to a server or a network, making it impossible for a legitimate users to access the service. Second is amplification attack. This type of attacks involves using vulnerable servers or devices to amplify the traffic or a request sent to the target server or a network, making the attack even more effective. Third is distributed denials of a service, DDoS attack. This type of attack involving using multiple devices or a botnets to launch a coordinated attacks on a server or network. To handle a DOS attack, there are several steps can take. First is identify the attack. Use monitoring tools such as IDS and IPS to identify and analyze the traffic or a request that are causing the DOS attack. Second is block the attack. Use firewall or other security technologies to block the traffic or request that are causing the DOS attack. Mitigate the attack. Use a technique such as rate limiting or traffic filtering to reduce the impact of the DOS attack and restore normal network operation. Fourth is prepare for a future attacks. Implement a comprehensive network security strategy that includes monitoring, testing, and incident response procedures to prepare for a future DOS attack. Overall, DOS attack can be a serious threat to network security, but with the right tools and strategies, it is possible to detect, block, and mitigate the effect of the attack. By understanding the nature of a DOS attack and implementing effective security measures, network administrators can help to protect their networks and its resources from this type of a cyber attack. Second is malware. Malware, short for malicious software, is software designed to harm or exploit a computer system without the user's knowledge or consent. Malware can take many forms including viruses, worms, trojans, horses, ransomware, and spyware. Once a malware infects a system, it can cause a wide range of problems from stealing and sensitive data to causing a system crashes and slowdowns. Malware can be delivered through a variety of means, including email attachments, infected websites, and malicious software downloads. To protect against malware, it's important to keep antivirus software up to date, avoiding opening suspicious email attachments or clicking on links from unknown sources, and regularly backup important data to prevent data loss in a case of an attack. Another example of a malware is a ransomware, which is designed to encrypt a victim's files and demand payment in exchange for the decryption key. Ransomware attacks can be incredibly disruptive and can cause significant financial and operational harm to individual and organization. Overall, malware is a serious threat to the security and privacy of a computer systems, and it is important for individuals and organizations to take steps to protect themselves against these types of attacks. Our last topic is phishing attack. Phishing attack are a type of a social engineering attack that attempt to trick a user into revealing sensitive information such as password or financial data by posing as a trustworthy entity. Phishing attacks can take many forms, including email, phone calls, or text messages, and often rely on creating a sense of urgency or fear to prompt the victim to take immediate action. Common types of a phishing attack include spear phishing, where attackers target specific individuals or organization, and veiling, where attackers target high-profile individuals such as CEOs, government officials. To protect against phishing attacks, it is important to be wary of unsolicited emails or messages. Always verify the identity of the senders before responding to a request for sensitive information, and use multi-factor authentication to add an extra layer of the security to online attacks. Here are some examples of a phishing attack. Deceptive emails. An attacker might send a fake email that appears to be from a legitimate organization such as bank or a social media platform. The email might ask to the victim to click on a link to reset their password or provide personal information. Second is spear phishing. This is a more targeted type of a phishing attack where attacker research their victim and send a personalized email that appears to be from a trusted source. The email might contain personal details about the victims to make it seem more convincing. Third is smishing. Smishing is a type. This is a type of a phishing attack that use SMS text message to trick victims into clicking on the links or providing sensitive information. The last one is phishing website. An attacker might create a fake website that appears to be legitimate ones, such as online banking portal. The website will ask the victim to enter the login credential which the attackers can then steal. Overall, phishing attacks are a serious threat to the security of a personal and a business's information. It is important to be cautious when receiving emails or message from unknown or suspicious sources and to never provide personal information unless you are sure it is a legitimate request from a trusted source. Congratulations, guys. If you like the course, please give us a 5 out of 5 rating and leave a comment about your favorite part of the course and share it with others. Congratulations on completing the networking fundamental for a ethical hacking course. You now gain a solid foundation in a computer networking relevant to ethical hacking and a penetration testing. You have learned about the IP, MAC and port numbers, different types of networks, TCP/IP protocol suites, application layer protocol. In addition, you have learned about networking security topics such as firewalls, VPNs, as well as tools and techniques for detecting and preventing cyber attacks. You are now familiar with the intrusion detection system IDS and intrusion prevention system IPS, and you know how to handle denials of service, DOS attacks, malwares, and phishing. We hope that you found the course informative and engaging. The skills and knowledge you have gained in this course will be beneficial in pursuing a career in a network security or a ethical hacking, or simply in understanding how network works and how to secure them. Thank you for your hard work and dedication throughout the course, and we wish you all the best in your future endeavors. Happy hacking!